Okay, folks, let's continue with part two of this video. So we were talking about how you create the Vinesh table, right? Remember we said A, B, C, D all the way to Z, and then in the next row you're going to start with a B, and now your A will go at the end, and then the next row you're going to start with a C, and the B will go at the end. So you're going to keep doing this until at the end here, the Z will be the first character in the row. You're going to see the Z right here, right? So that's how you create the table. Now notice the table has A, B, C, D in here in the column, and B, C, D the same thing in the column. Very important to note that. Now, this is the table. How do we encrypt? Let's suppose we're going to look at a message like attack at dawn. Now, you have to be careful. It doesn't deal with special characters, with spaces, and with certain characters. It doesn't do well with this. So it is a primitive cipher. So it doesn't really apply to what we do today. So it doesn't work in a as a modern cipher. So my key in this example is red. Actually, it's the word red. So in the practical scenario here, we're going to do red, and until it has the same number of characters as the text. This is the clear text. Notice that this is my clear text here, and this is my key right here, right? So if I had more characters, I mean, if I had dawn, please, right? So you're going to keep adding red, right? You're going to keep adding red, and so on, because you have to have the same number of characters at the top in the clear text as the key itself. Okay. Now, how do we encrypt? So remember, we have an A and an R. Let's go to the table and see what we are going to do here. A and R are not the best characters here because it's not going to take us, you won't understand it very much, but let's go ahead and do it. So we're going to be in row A, and we're going to go to column R. Guess what do we get? We just get an R. So if we go back to this, the first character in the ciphertext is just an R. Okay? So let's look at the second one. The second one will make a little bit more sense. So remember the next character, T and E, right? The clear text has a T and the key has an E. So let's go back here. So we're going to go to row T, and we're going to move over to column E, right? Remember, this is the column. T column E. What do we get? The ciphertext is an X. So here, we come here, the ciphertext is an X. Let me go to the next one. This time it's T and D. So let's go in the table. So we're going to go to a row T, and we're going to go over. You may want to use a ruler to make sure you get the right character. It is a W right here. So the ciphertext is a W. Okay? So what I want you to do is complete this on your own. Remember, this is the row, right? Remember, we are A and R. We'll give you an R. So you can check that for me. A C and E. A C and E will give you a C. So you're going to come down to row C, and you're going to go to E. So that gives us what character is this in this cross section? AG. So our ciphertext text is AG. So remember I said I was going to give you an exercise to do. So what I want you to do, I want you to complete this all the way to the end, and I want you to encrypt this one, right? So all people, oh, misspelling, will receive a gift for Christmas. Okay? Or for your birthday, whatever you want. And my key here is orange. So I'm going to keep typing orange. Make sure I don't spell anything. That's it. So just count the top. Remember, now what you need to do is remove the spaces, because spaces don't do anything, right? Well, I'm removing the spaces here. If you don't believe in Christmas, just put something else in there, right? And then we'll cut the end. Okay? Now I want you to use the table, an A and an O. You know what that would give us, an O. An L and an R. I want you to go back to this table, and L, go to row L, and move over to R, right here. What do you get? You get a D. Am I right? No, you get a C. Right? So your ciphertext will be a C. Now, there's no grade to this. This is just for your own practical purpose to do this, just to see how it works. You don't have to turn this in if you don't want to, or you can just send it to me, and I'll be glad to look at it and see if you did something wrong. Okay? Now, the last thing I want to talk about briefly here is what we call complexity. How complex is an encryption algorithm? How do we decide how good an algorithm is going to be? Now, the way I am going to explain this, although we won't need this much later in this class, is with a simple example of the addition of two rows of binary numbers. Remember, binary numbers have ones and zeros only, right? So we're going to add them, right? So to add them, all you have to do is take 1 plus 0. The answer is what? Let me tab over here and give you an answer. 1 plus 0 is a 1, right? Let's line it up. I can't seem to get this to line up here, but let's see if I can. So it's a 1, right? 0 plus 0, again, that's a 1. I'm doing this backwards, but just to show you how this works. 1 plus 0 is a 1, just regular addition. 0 plus 1 is a 1. 1 plus 0 is a 1. 0 plus 1 is a 1. 0 plus 0 is a 0, right? 0 plus 0 is a 0. How about 1 plus 1? 1 plus 1 in binary is a 0, and you carry over 1. Okay, remember that. 1 plus 1 is a 0, you carry over 1. It's like adding 5 and 5. 5 and 5 is 10. You put a 0, and then you carry over 1 to the next column of the addition. Okay? So, I mean, you don't need to understand binary bits in detail here, but you just need to understand how the addition occurs for binary. You just keep adding them, right? For each number on top, you'll add it to a number at the bottom. But what if we have to multiply these two numbers? If we need to multiply these two numbers, these two binary numbers, it gets very complicated. You have to take a 0, just like you would with anything else, with a regular multiplication. 0 times 1, 0 times 0, 0 times 1, 0 times 0, 0 times 0, 0 times 1, 0. And of course you're going to get 0 because 0 times anything is 0. Then what do? Then you go to 1 times 1. Then you're going to go to 1 times 0, 1 times 1, 1 times 0. You keep doing this. And then you go to the third number here. You're going to do the same thing. You're going to go to the fourth number and you're going to do the same thing. So if you have 10 numbers on top and 10 numbers at the bottom, you're going to do this 100 times, right? 10 to the power of 2. Does that make sense? So here it gets a lot more complex. In terms of complexity, we say this is a quadratic complexity. Remember, it's twice as, remember, 10 to the power of 2. It's called a quadratic complexity. And quadratic complexity is fine. There's no issue with it. We can do this in real time. Computers can get this done very quickly. But one type of complexity that we cannot handle, that's not possible, is exponential complexity. So remember, exponential, the number of iteration goes up very quickly. For example, 2 to the power of 0 is 1. 2 to the power of 1 is 2. What happened next? 2 to the power of 2 is 4. 2 to the power of 3 is 8. Remember what's happening to the answer here. It's getting bigger and bigger and bigger very quickly. 2 to the power of 10 is a huge number. 2 to the power of 100 is a huge number. We call this exponential complexity. And when we deal with complexity, we use the term big O, right? This is a linear complexity. This is a quadratic complexity. And this is an exponential complexity. We're going to need that a little bit later when we talk about brute force attack. So keep that in mind. And we're going to end it here. And we'll have, hopefully we won't get any glitches next time. And the recording will work much better. Good night. Talk to you on Sunday.